Hello guys, this is Code and Code and this is 6th lecture of string algorithm series. In this lecture we are going to study KMP string matching algorithm. So about the prerequisites, we only need very basic requirement to understand the KMP algorithm working. We need the knowledge of, you need to have the knowledge of prefix and suffixes of a string and just a basic of programming and you will be good to go. So what is KMP algorithm? So KMP algorithm actually is a string matching algorithm, as you already know, and for its implementation it depends upon the prefix function. So we'll be first studying prefix function and then we'll be moving on to understanding KMP string substring search algorithm. So the prefix function has this definition. Prefix function will be storing as it is also known as the pi function. That is why I've written pi here. So we'll be storing it as an array, integer array. So pi of I would be the length of the longest prefix of substring 0 through I, which is also a suffix of the substring, right? And here we are talking about the proper prefix. Proper prefix of a substring is a substring or a prefix which is not equal to substring itself. So if I'm talking about the substring ABC, then if you are talking about the prefix or suffix ABC, then these are not considered as proper prefix or suffix because they are equal to the substring itself. So the proper we here only will be considering the proper prefix or suffixes for calculation of prefix function. Now, first of all, what is prefix function? As I already told you, KMP algorithm completely depends upon prefix function for its implementation. So prefix function, the definition we have already seen. This is an example of prefix function. So here you see for I is equals to 0, I'll be considering 0 based index system. So a character A is at index 0, this is at index 1 and so on. So we are using here the same index system which is strings use. So we will be using 0 based index system. So pi of 0 would be 0 because it has no proper prefix. Pi of 1, it has one proper prefix, that is A, right? The whole substring is AB and the proper prefix is A. So proper prefix A is not equal to proper suffix of length 1. Length 1 proper prefix is only A and length 1 proper suffix is only B. A is not equal to B clearly, so the answer is 0. Similarly for A, for this ABCA string, if we see proper suffix A is equals to proper prefix A, and that is why the maximum length suffix which is also equal to prefix is 1. That is why pi of 3 is 1. Similarly for the rest of it, you can read more about them on the cpalgorithm.com. The link I'll be posting in the description of the video about the prefix function, because I already told you this whole course I am following cpalgorithm.com as a reference. So I'll be providing the link in the description so you can learn more about the prefix function. For example, for here you can see the prefix AA matches the suffix AA matches prefix AA, and that is why the prefix function, the value of pi function at this index is 2. For this, AAB matches the prefix, the suffix AAB matches the prefix AAB, that is why pi of this index is equals to 3. So the question is how you can compare. It is easy. For example, if you are going to calculate for substring 0 through this, how many characters? The 4 is 7. So 0 through 6. What you can do, you can first compare length 5 prefix and suffix. Length 5 prefix is A through this, I guess. Okay, 6. So you can start since the whole string, I'm talking about the substring 0 through 6, right? How many characters? Sorry, 7 characters. Yeah, so indices are from 0 to 6. If you want to calculate pi of 6, then you would since there are 7 characters, you would start with 6 character prefix. So 6 character prefix would be AAB triple A, and you will be checking whether this 6 character prefix is equals to 6 character suffix or not. So we see 6 character suffix is AB or triple AB, which is not equal to 6 character prefix. So 6 is not the answer. Then you will be going for 5, and then you'll be checking for 4, and then you'll be checking for 3. So 3 character prefix is AAB, and 3 character suffix is AAB as well. So you can see 3 character prefix is equals to 3 character suffix, and that is why the answer is 3, which is the maximum you can achieve. So that is why the prefix or the pi of index 6 is equals to 3. Now the naive approach, you can use the naive approach to calculate this, and if I show you here, this is the code. Let me increase the font size. On the cpalgorithm.com, the link I'll be providing in the description. So this is the naive approach you can apply, where we are running two basically nested for loop and checking the substring. The overall complexity is n cube. You can read about it. This is very basic, so I'm not going to explain this. You go there and try to understand that algorithm. That is very easy. The thing that I have explained here, that go for 5 character prefix and suffix, then go for 4 character prefix and suffix, that is exactly what is happening there. Understand that first before moving on, because understanding of how prefix function actually is calculated is very important. Speaking of algorithm, one of the best learning platform, Unacademy, and one of the best practicing platform, CodeChef, are coming together to help you get better at programming and problem solving skills. Unacademy knows how important it is for you to monitor your progress throughout the course, so they have provided a series of mock tests which will help you monitor your progress throughout the course, which you can take, and which will also help you analyze the area which require improvement. These courses provide right kind of guidance and structured learning for every level of programmer, whether you are a beginner programmer who has just started with competitive programming, or an intermediate or advanced level programmer who wants to get better at competitive programming. Unacademy has Summit Batch, which can help you improve your chances of getting placed in fun companies. It can also help you crack international coding competitions like ACM ICPC. Not only that, if you go for 6 or 12 month subscription, you are eligible for industry accepted CodeChef certification. It has just started this week, so go and join quickly. You can use my referral code and get 10% off on any subscription plan. There you go. So let's head back to our lecture. Now that you understand the working of prefix function, now let's go back and see this code. You see, this is the most expensive operation where you are comparing two substring. When you compare two substring, you know it requires big O of n time. Since we are not using hashing here, it requires big O of n time if the substring are of length n, right? And because of this, we are getting an extra n factor in the overall complexity. So the question is, can we improve this comparison? So first thing, one of the most important observation is this. We'll be trying to come up with an algorithm where we do not have to compare the substring. How will we do that? This is one of those important observations. There are two important observation or improvement that we can make. This is one of them. So the important thing to note here is that the prefix function can only be increased at most by 1. So basically, pi of I plus 1 would be less than equals to pi of I plus 1. So basically, it can increment at max by 1. So here you see, it was 0, so it is incremented by 1. Again here, the next is incremented by 1 only from the previous one. And this is not incremented at all. This is incremented by 1 only. So we can increment at most by 1. It is possible that it decreases. That is possible. It can decrease by it can decrease and go up to 0. That is possible. If I were to add x here, I guess the next pi of the next index would be 0. It is possible that it falls to 0. That is possible, but it would not increment by more than 1. At max, it can increment by 1 from the previous pi value. And how we are gonna prove this? It is very simple to prove. You can prove it using contradiction. So I would like you to try it yourself. Otherwise, I'm going to explain it with an example. This example you can replace with variables and make it a general case. I'm only taking special case so that you can understand it understand it better, and the proof remains the same. You can replace these numbers with variables and you will be able to generally prove this, what I'm going to show you. So see, suppose we are assuming we'll be proving it by contradiction, of course, because pi of I plus 1, I've taken 5, which is incremented by 2, right? So of course we are going to prove it by contradiction. So let's assume pi of I was 3 and pi of I plus 1 is equals to 5. See here, let I be 8, index I be 8. So pi of I is clearly 3 because S6, S7 and S8 matches the first 3 characters. So basically these 3 characters of the suffix of length 3 matches the prefix of length 3. I'm considering I is equals to 8, right? So pi of I is equals to 3. Now I'm saying that pi of I plus 1 is actually 5, which is being incremented by more than 1. We are saying that it cannot increment by more than 1, but here we are assuming, like, let's assume that okay, it can increment by more than 1, and so I am incrementing it by 2, or you can take any number here, 2, 3, 4, 5, doesn't matter. So I'm assuming that I of 9 is actually 5. If that is true, so you should see here that if that is true, if pi of I plus 1 is equals to 5, that means the last 5 character ending at index 9 match to the first 5 character. Basically this suffix is equals to this prefix, right? What I can do is that I can take this suffix, remove the last character, and this S5, S6, S7 and S8 must match, right? S0, S1, S2 and S3, right? Because pi of 9 is equals to 5, that means these 5 characters may match the first 5 characters. That means if you ignore the last character and only consider the first 4 characters, they must match the first 4 character, right? If that is true, then the pi of I, which is index 8, pi of I should have been 4, not 3, right? So we are reaching to a contradiction that pi of I is actually 3. It shows that if pi of I plus 1 I am considering 5, then pi of I should have been 4, not 3. And then we are reaching to a contradiction that it should have been 4, not 3. And that is why this claim is actually false, and hence our original claim is actually true. So you can use variables here, and using the same set of argument you can prove using contradiction. I hope you are understanding what I'm trying to say here. If you are not able to understand, just go through the article there on the cpalgorithm.com, the link which I'll be providing in the description. If you are not able to understand, even though, please mention it in the comment section. I'll be trying to help. So this way you can prove. So now we know that prefix function increments at max by 1, right? Now how is that gonna help us write an algorithm which is efficient enough? So let's see how. So clearly this I have already mentioned, the cubic algorithm, or the cubic complexity is because of we are comparing each character, because when you are comparing two substring, they are actually being compared internally by their characters, right? So can we bypass the string comparison? Now we are gonna answer this question. So see here, this is another improvement, and this is an important condition. See here, suppose from 0 to I minus 1, I'm considering this index to be I minus 1. I've already calculated, right? Pi function from 0 to I minus 1, I've already calculated. Now I'm going to calculate pi of I. To calculate pi of I need to do this. I mean, what I have to do, we already know that pi of I minus 1 is 3. So pi of I can be at max 4, right? So if pi of I is actually at max 4, that means these 4 characters must match. Should I compare all of these 4 characters with these 4 characters to see whether the pi of I is going to be 4? The answer is no, I don't have to. Why? Because pi of I minus 1 is 3. That means the first 3 characters already are matching. So I don't have to compare the first 3 characters. I only have to compare the fourth character. So there is only one comparison. There are not, all of the characters are not being compared one by one. Only the last character is being compared. So pi of I minus 1 is 3. That means first three characters are already matching. If pi of I had to be 4, then the fourth character must match the fourth character of prefix, right? Fourth character is prefix is at position pi of I minus 1, right? So that is why I'm comparing the fourth character, which is pi of I minus 1th character of string, to the ith character. I don't have to compare all of these three because they already are matching, because pi of I minus 1 is already 3. So I'm comparing the fourth character with the ith character. If these match, then the prefix, the pi of I can be pi of I minus 1 plus 1, that is 4. Try to understand this. This is very easy to understand, I think. This should not pose any threat to you, and try to understand this. So this is very important observation, and this way you can see we are not comparing the substring. Actually, we are only comparing a single character, which will require big O of one time, basically constant time comparison. Now the question is, what happens when the last character do not match? What if s of pi I minus 1 is not equal to s of I? What is going to happen? I'm going to stop the lecture here, and I'll be uploading the next lecture tomorrow, because the video has already gone lengthy. So I'm stopping here. If you have any doubt or query, try to understand till this point. If you have any doubt or query, you can ask me in the comment section below. So thank you guys for watching, and till the next video drops, keep coding. Thank you.